when ethanol is burned? Complete the box to name the apparatus. So what we call this? A beaker. Why water collect in the YouTube? So what is the reason why we collect a water in a YouTube? We are burning ethanol, combustion of ethanol, yeah, due to condensation. But this is of 2 marks, so the distribution of the marks, because what happened, the steam or the water vapors condenses or cool down. So 1 mark is for mentioning condense, 1 mark is for water vapors. So steam you can mention, or water vapors
Steam
condense,
condenses.
yeah, to form water. Then state a chemical test for water. How we can test the presence of the water? Chemical test. The chemical test to show the presence of the water.
Copper 2 sulfate.
Copper 2 sulfate or cobalt 2 chloride anhydrous. So you, and it, if it is copper 2 sulfate, it will turn from white to blue. If it is cobalt 2 chloride, it will turn from blue to pink. So you can see anhydrous, copper 2 sulfate or cobalt 2 chloride. It will turn, if cobalt 2 chloride is there, it will turn from blue to pink. And if copper 2 sulfate is there, it will turn from white to blue. Then what is the purpose of the suction pump? What is the reason why we are using a suction pump? So that the product can move through the apparatus. Because what happened,
To remove
ethanol is,
anti-gravity.
or move, so that the product can move through the apparatus. Because what happened, when ethanol is there burned, it produces carbon dioxide and water vapor, so they can escape from the surrounding as well. This suction pump which reduce the pressure, so force the uh, product to move through the apparatus. So the product will move through the apparatus, or remove the gases, you can also mention. Predict the change seen in a test tube containing a lime water and explain your prediction. So what will observe a lime water? Because ethanol is burned, it produces carbon dioxide and water vapor. So what happened to the lime water?
Escapes as a gas.
No, carbon dioxide is there, which is passing through a lime water. So what will be the effect of carbon dioxide on lime water?
It will react with it and it will form.
So if lime water is there, it will turn milky because of carbon dioxide.
Yeah, it will turn milky.
And why turn milky? Because it form, lime water is actually calcium hydroxide. So when carbon dioxide mixes with calcium hydroxide, it forms calcium carbonate. So the lime water will turn milky because of carbon dioxide. The second question, a student investigated the rate of a reaction between nitric acid and excess of magnesium carbonate at room temperature. The apparatus was set up as shown in the diagram. A small test tube is there, which contain a magnesium carbonate suspended in a conical flask. And then when we remove this thread, a test tube will mix, the content in a test tube will mix with nitric acid, and this will result in a formation of a carbon dioxide. A 250 cm cube measuring cylinder is inverted over the water. 50 cm cube of nitric acid was added to a conical flask. The content of the test tube were released and allow the solid magnesium carbonate to mix with nitric acid. The stop clock was started and the volume of the gas collected in the inverted measuring cylinder every 10 seconds for 80 seconds. So use the inverted measuring cylinder to record the volume of the gas collected. So what is the volume of gas collected when time is 0? That's 0. When time is 10 seconds, what is the volume? 27. Because it is inverted, like a 0 is there top, so this is 25, 6 and 7. Then when time is 20, what's the volume? 48. Because I will zoom in, so it will be easy to read this. So you can see 45 is there, 46, 47 and 48. So it will be 48. Then 62. Then 65. And 76. 74, 76, 76. And 74, 76, 77. Yeah. So if I complete this table, because we have to use this table to plot the graph. So first it was 0, then it was 27, then it was 48, 62, 65, 74, 76, 77 and 77. These are the values. Then we have to plot the total volume of a gas collected with the time. So first when it was 0, the first value was 0, 0, then 27. Roughly I will sketch the graph. So 0 and 0 is there. Then at 10 it was 27. So at 10 it will be 27. And at 20 it was how much? 48. At 20 it was 48. Then at 30 it was 62. And at 40 it was 65. And at 50 it was 74 and then 76. and then at 60, 76, and 77 and 77. So when we sketch these points, one of the point appear to be not in the same pattern, and that is anomaly, means a random result is there. So you don't have to join that point, you have will leave that point, anomalous value. So as they ask in the question, one of the point is anomalous, circle that point on your graph. So the point which is not appearing or coming on a smooth line, so you will just circle on your graph. Then from your graph, deduce the time taken to collect 40 cm cube of gas. So 40 cm cube of gas, how we can work out how much time taken to collect? So we'll draw a line from 40 cm cube and then find the time interval. According to the graph, we will write the answer. In this question, state one possible source of error in the experiment and suggest one improvement to reduce this. So what we are doing in this experiment, we are measuring the volume of the gas using a measuring cylinder. We took 50 cm cube of nitric acid. So what might be the sources of the errors? You can see use of the measuring cylinder, because the measuring cylinder, it's a 250 cm cube measuring cylinder, so its reading will not be that accurate. So what we can do, we can use a gas syringe or a smaller measuring cylinder to have more accurate result. In chemistry, we normally don't mention, because if you check the question, in the question they ask, as you see the question, one possible source of error in the experiment and one improvement is there. So for that source of error, so normally in chemistry we don't parallax error, the we don't write that. It's like mainly because the apparatus which are used are not accurate, so that is creating a greater error. That's why we'll use a measuring cylinder of small measuring cylinder or use a gas syringe. Then the average rate of a reaction can be calculated by using the equation. Calculate average rate is volume of the gas collected divided by time. Calculate the volume of gas collected between 10 second and 30 second. And then calculate the average rate. So how to calculate a volume of a gas collected between 10 second and 30 seconds? So what we will do, as we know, this will be the graph. The shape of the graph, example, this was the graph which we obtained. So first we'll find what is the volume at 10, and then we'll find what is the volume at 30 and take a difference to know what is the volume of a gas collected from 10 seconds to 30 seconds. And you will get that value. Then to calculate an average rate, it will be time taken, because from 10 second to 30 second it's 20, so volume is already there. You calculate, you get the volume, and that volume divided by 20 seconds, because from 10 to 30 seconds the interval is 20, you will get average rate, which will be centimeter cube per second. The student calculated the total volume of a gas collected in this reaction would be 85. Suggest an explanation why the actual volume of a gas collected was different from 85. Like a student suggested that 85 cm cube of gas should be collected, but in practical he's not collecting 85 cm cube of the gas. What might be a reason? The reason is the solubility of the gas, because this is a complete sealed, like the apparatus is completely closed here. There is no outlet except it can enter the maging cylinder. So basically what happened, because when the gas is given off, some of the gases are water soluble. So this gas is passing through the water and then it is collected. But what happened when the gas is passing through the water, some of the gas may dissolve in water. That's why we are not getting the same volume of a gas which we should collect. So volume of the gas is will lower. Why it is lower? Because the carbon dioxide, as we know, the carbon dioxide gas will be there. Carbonate is reacting with acid, so it dissolve in water. That's why we are not getting the same amount of same volume of the gas which a student predicted. Sketch on the graph a graph you expect if the experiment was repeated lower temperature and label that graph as L. So if this was the original graph, if this was the original graph, so at higher temperature, at lower temperature, it will be less steeper, but the final product will be same. So it will be below or less steeper, where the final product should be same because we only change the temperature. Changing the temperature changes the rate of the reaction, but amount of product remain unchanged. Now in the next question, this is about salt and identification. Two substances, solid A and solid B, were analyzed. Solid A is a zinc nitrate. Tests were done on the substance. Test on solid. So about solid A, they already mentioned it is zinc nitrate. So zinc is there and nitrate ion. So this will give a positive result if we carry out a test for zinc ion or we carry out a test for nitrate ion. Complete the expected observation. The solid A was added to a distilled water. The mixture was shaken to dissolve. Produce a solution. The solution was divided into three equal test tubes. Few drops of sodium hydroxide were added. If I add sodium hydroxide and I have a zinc salt, I have zinc, what will be the observation? It will be white precipitates, white PPT. You can write full precipitate or you can write PPT, both are acceptable. An excess of sodium hydroxide was added. If we add more than enough sodium hydroxide, so white precipitate, it will dissolve. In excess of sodium hydroxide, you can see the precipitates dissolve and it will form a clear solution. If it was a colored precipitate and it dissolved, then it will form a colored solution. But because it's a white precipitate, so it will form colorless solution or clear solution. A few drops of aqueous ammonia was added to the second portion in solution A. What is the observation if we add aqueous ammonia to a zinc salt? White precipitate, and in excess, what happened? If you check for zinc, again it will dissolve, form a zinc precipitates are both water soluble. We have to recall that table. So precipitate dissolve to form a colorless solution. Next is aluminum foil was added and sodium hydroxide to the third. So aluminum powder or aluminum foil and sodium hydroxide, and when we heat and test the gas. That gas is actually ammonia gas is released when nitrate. This is actually a test for nitrate ion. So when test for nitrate ion is done, we add aluminum powder followed by sodium hydroxide and heat. This will release ammonia gas. So if ammonia gas is there, what is the observation? A mixture was gas produced, tested with a litmus paper. So it will turn blue. Pungent gas will be there, bubbles gas will be there, and the litmus will turn blue. Even pungent gas is acceptable because that is ammonia gas. Yeah, one mark is for mentioning the bubbles gas, and the second mark is for mentioning the litmus paper turned blue. Test on solid B. So solid B, they did not give anything about solid B. Tests on solid B. Some of the tests and observation are shown. A flame test was done on solid B. A red color flame is there. So it confirmed presence of the lithium Li. You can see Li is there. And the second one, dilute nitric acid followed by silver nitrate. This is a test for halide ion, chloride, bromide, or iodide. If it is chloride, it will give white precipitate. Bromide, it will give yellow cream precipitate, and iodide, it will give yellow precipitate. So these yellow precipitate are due to silver iodide. So this confirms the presence of that it contain iodide ion. Identify solid B. So we identify from a flame test it is lithium, and we identify from silver nitrate that it is iodide. So the compound is lithium iodide. So this compound is lithium iodide. The last question of paper 6. Iodine dissolved in two different solvents, ethanol and hexane. Plan an experiment to find out which solvent iodine is most soluble at room temperature. You are provided with iodine, two solvent, and a common lab apparatus. And it's of 6 marks. So simply you have to find which solvent dissolves highest amount of iodine. Iodine is soluble in both ethanol and hexane. So what we can do, the steps, first we'll take known volume of ethanol and hexanol, hexane, sorry. So ethanol and hexane will take equal volume. Then add a known mass of iodine, stir, then filter, then dry and reweight, and repeat with hexane and conclude like, because basically we want to find which one dissolve the greater amount of iodine. So what we will take equal volume of two solution. That's first thing. You in exam you can mention the apparatus also, like which apparatus by help of measuring cylinder or pipette or burette. Measure mass of iodine by balance. Add equal amount of iodine to both solutions, both solvents, sorry. by help of spatula you can take, then stir, then filter to remove undissolved iodine, then dry and measure the mass of iodine again. Then how we can know which one dissolve having a higher solubility or can dissolve greater amount? The solvent which is having a small amount of iodine undissolved, having greater solubility. So these are the steps, the points which you will identify the one which is having a small amount of iodine. Take lead to color change. Actually, yeah, you can compare because both are dissolving. So you can identify from the colors as well, the intensity. If it is having a greater amount dissolved, so it will be darker in color. You can recognize from that. But that is a qualitative analysis. Qualitative means like just without measuring anything, you're saying the result. But conclusion should be based on the experimental procedures. That's why we are measuring the mass. But it can also be done. This is how you can solve a question. Is it clear? So you can see the points here, the distribution. We should have the known volume of ethanol or say hexane should be there. Known mass of iodine, stir, shake, filter. How much undissolved is there? Repeat. So this is like you don't find the exact any type of experiment in the book, but it's based on your understanding how. So it's your general understanding of the chemistry. It's not having a specific chapter that you are learning how to identify the solubility. So you can plan experiment in your own ways. If it is valid in terms of chemistry, then you will get